All right, go ahead.
Okay, well, let's start the meeting. This is the Tangerine SDR and Hamside Personal Space Weather Station technical talk for February 23rd, 2021. And my name is Dave, KV0S. And this week I've been working a little bit on a programming emulator. So I made some progress over my impediment that has gotten my way for the last couple weeks. It's one of those things that you work on and finally you fix it, and it seems really simple once you figured it out. So anyway, that's me. Other than that, let's see. I've been working on just doing some whisper beaconing and still have magnetometers running steadily, collecting data. So that's it. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. It's been a busy week here. I've been working with Bill Engelke on a little project, so that's coming along. And I've also been getting the Hamside workshop in order. The committee met on Friday. We went through abstracts, and we have a draft order agenda set. So it's not finalized yet, but it's looking pretty good. So I could probably give more information on that later. W2NF, back to net.
Fine business. And next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, good evening, Dave, and good evening to the net. Played around a little bit this week with the grape image, and now I have the ability to make the system, make everything, data collection and everything start automatically upon boot up with a little bit of delay so that the network, well, configurable delay, so that if you want to run NTP, it takes so many seconds to synchronize the clock. And I figured out how to make an image of that and was able to upload it. So the image in raw form is something like about 50 gigabytes, but when you compress it with gzip, you can get it down to about 5.5 gigabytes, which allows it to be uploaded to Box. So Case Western Reserve was able to retrieve that. So we have the ability to get that transferred to them. Also, I played a little bit further with the being able to store and reveal, or rather store and analyze data using digital RF. I found out that it is possible to store on the grape. We're running the chip, the sound chip, at 8 kilosamples per second. And I found out by talking to John that I was concerned about there might be some artifacts, but then I found out that John has a roll-off filter in his grape radio, which starts rolling off about 1.6 kilohertz. So what's interesting about this, it means I don't have to worry about filtering the 8 kilohertz sample because there's nothing much higher than a couple 3 kilohertz in the sample. But the downside of it is if you've filtered out that much, you can't listen to the thing for the voice announcements because they're all higher in frequency than that. So it means with the grape, you can't really listen to them. I mean, I was able to set up the audio sync on GNU radio and plug in a set of headphones and hear the central tone, and it's there, but you don't hear the voice announcements. So, but anyway, I was able to store these in digital RF and was able to bring them back and then play them at a very, very narrow bandwidth, so we can see the Doppler shift very cleanly and very nice. And it's captured very nicely in the digital RF in a single channel. At first I was kind of confused about that, but Nathaniel gave me some pointers. Tom McDermott had given me some pointers about this, and I was able to prove myself experimentally that it seems to work. It's sometimes a little bit blocky or pixelated or something, but that's probably a tweak that we can take a look at. All of that is going to be applicable going down the road to the Tangerine data. That's one of the reasons why I'm playing with that. So, okay, back to Ned.
Well, fine business. I will let people know I seem to be dropping out every so often. So if I disappear, that's the problem. I'll try to get back. Next on the list is Dev. Go ahead, Dev.
Good evening, everyone. So we have started a new week, and today I taught my first class for this semester. And I think it went okay. It was a good experience for me to teach after a long while. So I think we're starting on a positive note. Other than that, I don't have made good progress with the research. So I need to catch up. Thank you.
Fine. Fine business, Dev. And next on the list, we have Jim, K4BSE. Go ahead, Jim.
I was concerned after last week's meeting where we're trying to pull out WWV down in South at the South Pole, and concerned about other stations and the same frequencies. So I started constructing a spreadsheet with all the standard stations I can find that are on 5, 10, or 15 megahertz. I'm getting some others along the way too. And the bottom line is there are several of them. There are about 3 10 megahertz stations in South America on, on 10 megahertz, I just said that, redundant. And a handful in other parts of the world too. I sent a early version of that spreadsheet to Christina this afternoon. I tried to post it to the reflector and it wouldn't go. Probably, I assume the reflector just doesn't like attachments. I don't know how to get that distributed without sending it as an attachment. I think there is some cause for concern there. Are we really going to be able to hear WWV over the other stations reliably? That's about it.
Thank you for doing that.
Yeah, Nathaniel, you want to take over for Dave? It looks like he's frozen.
Oh, okay. So sure, I can do that. Thank you very much for doing that, Jim. I appreciate it. And we'll have to talk with Christina about that. It
Nathaniel
looks
looks
like we're learning
frozen too.
I'm frozen too.
But not-
Oh, but in a different way, right? Yeah. And I guess it's good to know. I didn't realize about that filter that was on the group either. So that's good to know. Okay. So next on the list, let's go to Greg, VA3CBN.
Thanks, Nathaniel. I got a few things on the go, but they're not related to your group. But I joined the Long Island CW Club last week, and I'm also taking an advanced course for my amateur radio, so I'm involved with that. I have a question for you guys, or Nathaniel, or whoever wants to answer. You always talk about, or most of the time, magnetometer. Can someone explain it to me in layman's terms, what a magnetometer is?
All right. Thank you very much, Greg. I will, in that case, call up Hyomin next, who can answer your question. Go ahead, Hyomin.
So you have a question about magnetometer in general?
Yeah, to someone that doesn't know about, like, in layman's terms.
Okay, so I mean, simply speaking, it's an instrument that measures magnetic field. In this context, we are interested in variation of magnetic field in low frequency, which is about hertz range magnetic field. So we are employing a very inexpensive magnetometer, which costs about, I guess, $20 or so, so that we can measure the context level of magnetic field variation of the Earth to understand how the solar activity affects the geomagnetic field around the Earth. So that is the main purpose of this project. So I mean, magnetometer in general can vary in terms of performance level and in terms of like price range, like going from like dollars to, $1 million. We're talking about really, really low cost magnetometer, which is not great in terms of scientific investigation overall, but for a general sense, we can have closely spaced array of magnetometers so that we can see the full context of space weather, in a more global scale. Although we have to compromise the performance level. Does that answer your question?
Yeah, thank you very much.
Okay, Human, do you have any other comments?
Do I have any comments?
Yeah, to say hello to.
Oh, is it my turn?
Yeah, it's your turn.
Okay, so well, since good evening everyone. So nothing. I mean, it's been pretty busy week for me. But there has been no really big progress from the ham side perspective, other than some discussion going on with other scientists in preparation for the total eclipse that's coming up this winter. So one of my colleagues is actually talking about, he's actually running a meeting actually tomorrow, where I think Nathaniel is going to be joining too, right? I guess. To talk about how solar eclipse will affect ionospheric dynamics, so that a number of scientists will get together tomorrow to discuss, our scientific objectives, as well as some kind of campaign utilizing many instrumentation that we have down there, including super darn, HF transmitter and receiver, magnetometers and stuff like that. So of course, what Nathaniel is doing right now is going to be highly relevant to this context. So otherwise, things are going along, and back to Ned.
Thank you very much, Human. Dave Witten, KD0G.
Hello. I've been working on some stuff with WX Python, wrapping Hillman's script to analyze the logs into a small visual app. I don't know, am I coming through? I don't seem to be appearing.
Yeah, you sound fine.
Okay.
Yeah, you look good too.
Okay, I don't even see myself. So, but anyway, I've been playing. I got tired of fooling with C and decided to play with black boxes again. So I've been using WX Python, just kind of the other end of the scale. Other than that, not much of interest to anyone, I don't suppose. That's it.
Thank you very much, Dave. Let's go to the other David McGaw, N1HAC.
Hello, everyone. For the question on what is a magnetometer, the simplest answer is it's a compass. We're using 3-axis magnetometers, but it really is just a fancy way of measuring the Earth's magnetic field like you would with a compass. And I'm busy right now. We've got a sounding rocket that's getting hot, ready to launch in May. the VLF propagation experiment flying from Wallops, Virginia. So that's kind of taking my time at the moment. So back to Net.
Thank you very much.
Where is it going to be
and
launched
next-
from?
From Wallops Island, Virginia, out on the eastern shore.
And let's see, thank you. And next, James Wolford, KG4DSG. Hey, nothing heard.
Mike,
Yeah.
Mike's
I don't know,
muted.
that mute doesn't want to, you got me now? You got audio?
Yes,
Yes.
go ahead.
Okay. I don't know why that button doesn't want to work, but it doesn't. Just listening in, trying to tear apart a dead tower that apparently ate a CPU, and trying to resurrect what I can. With that, back to the net.
Thank you. Dave, do you want to keep going?
Okay, I'm back and right now it's working. So, have you done Kong yet?
No, you should welcome Kong.
Oh,
Hello,
welcome,
everyone.
Kong.
Yeah, I should introduce myself. I guess my name is Cuong Nguyen. I'm from Vietnam, and currently I'm a student at the University of Scranton, with Dr. Fizel here. So I'm a student majoring in computer engineering and computer science. So that's why I have so far I have a little bit of knowledge about FPGA. So I was just talking to my engineering professor, and Dr. Fizel just happened to walk in and listening on a conversation, and just a coincidence that I'm here today. So currently, I'm not working on any research, but I did work on a little bit with quantum chaos last semester with another professor. So I'm looking for more interesting projects to join.
Well, I think Nathaniel has a number of interesting projects for you to get involved in. So welcome, and I'm glad to see you here. And please come. We meet every Monday night.
I will be here. Thank you.
Very good.
Maybe we can find something to have him help with the FPGA stuff.
Yeah, Scotty can use some help. Anyway, next on the list, have we had Dan yet? N4XWE.
Okay, thank you, Dave, and hello, everyone. Can you hear me okay?
Yes.
All right, perfect. Well, got a little problem with the new radio and scripts, and it really had nothing to do with scripts, but had everything to do with the new radio, and I think Dave just froze up again. So I kind of put it aside for a few days, and I'm going to go back at it. The issue I have is the new radio compiles without a problem, but the gr-grnet is still giving me issues. I'm able to, I've become quite an expert with Git here as of late, and I know that I'm downloading the correct source code for gr-grnet, but it refuses to find the makefile. And I don't know quite why. I don't know if it's some little issue that I'm not doing correctly, although I think I'm doing everything correctly, or if it's an issue with gr-grnet. So anyway, I'm kind of stuck on that, but I'll get that sorted out. So back to you, Nathaniel. I guess you're back in control of things.
I did come back.
Whoops, okay. Sorry about that, Dave.
It's kind of confusing tonight with it coming and going.
Yes.
So let's see. Dave McGaw talked, I thought. So has Jay talked yet? WB.
Hi, guys.
Okay.
Just seeing here as usual, just greatly enjoying it and learning all I can. Nathaniel, just to give you a heads up, just before the meeting today, I fired off a couple emails to you at your convenience. And I'm interested in still, if it's possible, to obtain a sensor package for use, to deploy a sensor package at my house here in the northern suburbs of Detroit. So that's one of the things I wanted to talk to Nathaniel about, or anybody else for that matter. So other than that, nothing really new here. Thanks, everybody. Take care.
Fine
Stay
business.
safe.
And next on the list, let's see, it'd be Jonathan Rizzo, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. I haven't really been able to do much. I started my new engineering job today. It's quite exciting. I also want to mention if anyone has not seen the video released by JPL about the Perseverance landing, the live video, it's absolutely amazing. And I would invite everybody to watch it. And maybe this could be for general discussion, but Scotty, I was wondering if you got any farther on the Raspberry Pi and the Beef module canal. Other than that, I don't have anything else. Back to the net.
Well, fine business. And then next on the list, we have Michael, AA8K. Go ahead, Michael.
Oh, thanks, Dave. Greetings to everyone on the conference. Back to you, Dave.
Well, fine business. And next on the list is Philip, N1DQ. I got it right, Philip?
Yeah, so this is kind of my first time here. My interest sort of arises, I run pskreporter, which has a kind of large database now of spots, which may be useful. The other thing that's sort of unrelated, but sort of related is I actually just got my first Meteor camera up and running. I'm in process of putting up my second one. There is a network of Meteor cameras, which you can build out of fairly inexpensively, that watch the night sky and report meteors centrally, where if two people catch the same meteor at the same time, then you can actually compute its orbit. So interesting stuff. Back to the net.
Very good. Hopefully I didn't get lost. It looks like I did.
Dave, are you there?
Dave's frozen again.
Frozen
I lost, all
I
right.
guess so.
They awful cold in this
All
room.
right. How about Veronica?
Hello, everyone. It's nice to see you all again. So over the break, Dr. Vercel was kind enough to let me borrow an IC7300, and that was very fun to get that set up. I now have an antenna set up at my house on my roof, and I was able to listen to a lot of different stations, which was very fun because my first actual experience with the real radio. Aside from that, I have a grape set up at my house now, and it's actively collecting data. And I had an altercation with my computer, so currently I can't really work on it, but I have been working on looking at the difference in time for when signals are received at my house with the grape and Dr. Vercel's house with the grape. And then also I am actively enrolled in Dr. Vercel's space physics class, which I'm learning a lot about the ionosphere and radio wave propagation and things of the sort. So that's all. Back to net.
Thank you very much, Veronica. That sounds excellent. let's go over to Scotty, WATFI.
Okay, I guess audio's where, there we go. Trying to get a new background up, but I wasn't fast enough. Anyway, good week this week. One thing I wanted to let people know is that the West Central Florida TechCon is coming up this weekend. And I know Tom and I are speaking there on Saturday. So I'll be talking about the Tangerine, and Tom will be talking about GNU Radio. He can fill you in more on what he's going to talk about. And let's see what else. I sent off a magnetometer, another magnetometer board set to Jules. He wants to, I don't know what he's doing out there. He's making these giant arrays of magnetometers, I think, because every time I talk to him, he wants another one to hook up to the same pair of wires, and so he can read like 3 magnetometers off of one wire. So it's very interesting. He's getting it working too. So I sent that off to him. In fact, he probably has it by now. Let's see, Jonathan, I do have the pinout defined. I looked at all your documents, and we can accommodate all of the I/O that you need. So I'm going to get you off an email momentarily and show you what I've gotten, and let you make sure that I didn't mess anything up. And I also got an email from John McGibbons. John, anyway, from
Gibbons?
Yeah, N8OBJ.
N8OBJ.
Yeah, and
Yes.
he gave me the pinout of the finalized pinout of the Grape Mark II, and we have all the I/O hooked up to that, so we're going to be compatible with the Grape. So that's good news. And the other good news is I actually finished the schematic for the data engine, and the CAD guy now is off working on the remaining models, CAD models. There's still a lot to do, but I told him that there may be some interconnect changes when I do the FPGA project, but there's pretty much not going to be any changes in components other than a few caps and resistors maybe. And also our parts procurement person is Nona, who was just in here a minute ago. She's working on costing it right now. So we'll probably in the next day or two, we'll have a BOM cost anyway for what the data engine is going to cost. And so that's some serious progress. A lot of long days this week spent on that, but so I've basically gone through and checked every component that was on the board to make sure I had the pinout correctly. And by the way, I found 2 errors. So it's good to check these things 2 or 3 times. And let's see what else. I want to talk to Nathaniel a little bit about some posters. We have an opportunity to get some science posters, some space science posters up before the Ham Expo in March. That's a week before HamSci, so this might be a really good opportunity to recruit some attendees to HamSci because it's the week before, or two. It's the 13th and 14th. So is that 1 week before? So
yes.
Yeah. So that's another virtual conference and supposedly I think 20,000 people attend this. It's a big conference.
Oh man.
They had one in October and they were just
We're gonna be busy.
Yeah. So anyway, so yeah, back to Ned. Thanks.
Thank you very much, Scotty. That sounds excellent. Let's go over to Tom Yarish. Tom, are you there?
I'm here. I'm working on another computer and I don't have much to say. Just wanted to check in with the group this evening and trying to get another machine up on Zoom and having my problems cut out for me here. So nothing to report. I'm working with the Hamcats group and Rob is pursuing his Whisper Demon adventures and nothing else comes to mind much, but we're all waiting for Tangerine to make its debut.
Thank you very much. Very good.
Thank you.
And
Bye-bye.
Next we have Tom, N5EG.
Oh, good evening, everyone. Yeah, I'm glad to see a good group. Not too much, just a few a few little conference calls on the clock and some other things. Not too much other activity this week. Back to the net.
Thank you very much, Tom. And Joe, W7 Lima Uniform X-ray. Joe there. W7LUX.
He's still showing his mic muted, even though there's no.
He's trying. His mic is blinking.
On the participants level, it still shows his mic is muted. So I thought, oh, they're switching around. So, okay.
Yeah. I think I got everyone then. Is there anyone else besides Joe that we didn't get? No. In that case, why don't we open it up for general discussion?
About Tom McDermott.
We got
Yeah,
Tom.
we had
Oh,
Tom.
got it?
Yeah.
Yeah.
Oh my God.
He was not last today. He was penultimate.
Hey, Tom, next time you change your login name to AAA Tom, and then you'll be first up.
Yeah, I can be quad A. I can be IPv6.
So, Scotty, very legitimately, are there any FPGA tasks students might be able to do or participate in? Even at a testing level, or?
Well, first thing to do would be to download the Altera toolset, the latest one, 20.1, the free version, and get that installed in your system. They have a Linux version and a Windows version. Doesn't matter, pick one that you're operating with, and get that up and running first. That would be the task.
Yeah.
And then when you get that up and
Do you
running,
have that all?
Pardon me?
Cuong, do you have that already?
No, I only have the Quartus program. We're using Quartus instead of.
So which version of Quartus are you using?
I'm using the latest version.
The which one?
The latest one?
Oh, okay. And okay. You got that all up and running on your machine, right?
Yeah.
Yeah. Okay, so yeah, so as soon as I get the base system made, I can send that to you. And if you want to take a look at what we're trying to do is build a self-test, because whoever we send the boards out to, the production boards out to, even the beta boards out to, they're going to have to do a test of the boards, because I don't want any boards back that don't work. And especially if we use an offshore manufacturer, you just can't be shipping batches of boards with bad boards in them. So we need to build a tester that we can send to the manufacturer to, and best is a pass-fail tester. We have lots of LEDs on the board. So I think it's typically we do loopback connections and just verify that, because we're not trying to verify any functionality of any parts. We're verifying solder joints. Shorts and opens is all we really need to verify, because we don't need to test the parts, because the parts are going to be most likely they're going to be good, but the most highly likely thing that's not going to be good is we're going to get solder opens or solder bridges. So that's what we got to test for, and we have to test all the paths whether we use them or not at the beginning, because they will be used eventually. So we got to make sure that they're all good on the board. So that's if you got any experience in that, or if you want to get some, that would be something that would be useful, I think.
Okay. That sounds good.
So it sounds like, if that sounds like something that you want to get involved in.
Oh yeah, I would love to.
Cuong, do you want to tell Scotty a little bit about what you're doing in class with Dr. Berger? Because Cuong was walking around with an Altera development board today.
All right. Which board did you get?
I got the DE10 Lite right here.
Oh, okay.
I don't know if you can see it. Yeah, so I'm still in the beginning of learning about this this board right here, and same thing with Verilog. I'm still pretty new with Verilog, but I had pretty long experience with programming, so I don't think that should be a big problem for me. And it seems pretty interesting. I didn't do much with the board yet. Let me actually.
Yeah, the hardest part with, if you have a software background, is understanding that everything works in parallel, not serially. And once you get your head around that, then it becomes much easier. So, and of course, obviously the programming you'll pick that up really fast if you've done other languages. But to understand that things are not serial, they're parallel, that's really important. And also to understand the synchronicity of everything. Make sure this crossing clock boundaries is what always gets people in FPGAs. So once you understand that, then those are two best concepts to get under your belt. And if you understand those, you'd be much better off. And I want to give a little example of, we were actually doing a project for a company that used a Cyclone 5 it was an optical scanner. And they were having a problem that the thing would crash every 10 minutes to 2 hours. But they couldn't predict when it was going to crash. It was just unstable. Okay, and sometimes it'd run for hours, other times it'd crash right away after you boot the thing up. And so they hired us to come in there and try and figure out what's going on. And they had like 20 or 30 files, Verilog files, that consisted of the whole project. So what it turns out, it took me 2 weeks to find this bug. Okay, now that's a long time I mean, they were expecting a fix right away, right? And I said, look, got 25 files. You don't get this in a day. Turns out what I had to do is I had to write down all of the destinations they had like 4 clock domains in the part. And you have to write down all the destinations of each of the 4 clock domains. And then whenever a signal crossed the clock domain, that's where you have to look. Okay. Turns out I found that they had 2 10 megahertz. They had a 10 and 100 clock domain, and they had used the 100 by mistake instead of a 10. I took 1 ASCII 0 out of the entire source code, and the thing worked. But it took 2 weeks to find it. So I referred them to you all have seen the Steinmetz cartoon, right? Where this was a guy that came in to consult for GE because they had this generator that was making a noise and they couldn't figure out what the problem was. And so they hired this genius Steinmetz to come in, and he says, okay, I want a cot, and I want a pad, and I want the door locked and no one in here. And I don't know how many days it took him, but he comes in, finally lets them back in, and there is an X marked on the outer surface of the thing. He says, it's under there. And they said, okay, that's great. And they start taking it apart, and they found the problem, and they said, how much will that be? And he says, $10,000. And they go, $10,000 just to put an X on the generator? We want to see an itemized bill for this. So he gives them an itemized bill. He says, placing an X on the generator, $10. Knowing where to place the X, $9,990. So it's all in knowing where to place the X, or where to take the signal and change it with another one to make it work. But yeah. So anyway, that's my classic clock boundary problem that you're going to see. If you work at FPGAs at all, you'll see it eventually. And especially if you work with old time hardware guys, you're going to see a guy that's going to take a D flip-flop and connect the clock and the D through an inverter, thinking that he's going to get a delay so that he gets the setup time for the flop. But then the compiler takes his gate out, and he doesn't get any setup time, and he just can't understand why it always goes metastable. Don't understand why it doesn't work right. So anyway,
that in a similar sense happened to me, a real life situation where the compiler messed me up at a work situation where we were trying to figure out why the watchdog wasn't working. And, we were going through the manuals and blah, 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 blah. And it turned out it wasn't our code. It was the compiler. It was the optimizer
that
was screwing us up. So when we turned off the optimizer for that section of code, everything worked fine.
So you got what you asked for without the optimizer. And
yeah, and it was only a few lines of code. It had to be assembly language. The nature of what we were doing, it had to be assembly language. So, but the compiler, because we were writing to the same address, we were setting flags at one address, bit 0, bit 5, bit 10, whatever. It just said, oh, hey, you've got 3 sequential instructions. They're all writing to the same physical address. I'll just combine them all in one write statement. And the hardware didn't like that. So that really happened.
Yeah.
Where the compiler, the optimizer screws you up.
Well, there's a very simple example of that where if you're building a flip-flop out of basic logic in a CPLD or whatever, there's a redundant gate in there that makes sure that it flips properly, and a compiler will take that out if you're not careful.
And it'll help you to make a mistake.
Yep.
Yeah, so really I guess the important thing is, I know Altera and Xilinx both have their campaigns to claim that you don't need to know anything to program FPGAs, and they all have software packages that try to help you and make it simpler and simpler. But there's no substitute for knowing what the logic inside the FPGA is. And I mean, you don't have to know down to like the old days of flipping bits on and off. And but you really, if you know the architecture, it helps you understand why things don't work. Because I've seen so many times people get so at such a high level, they paste all these blocks together, these IP blocks together, and the compiler helps them by connecting buses, point-to-point buses, by putting multiplexers in. So I think the AXI bus is like that. It's a point-to-point bus, but you want to hook 3 things on it. So it puts a multiplexer in there for you. Well, that's great as long as it works. But if it doesn't work, you don't know what to do, because it's all been done for you. And now you don't have any visibility into what actually happened. So it's really good to do some debugging. And with Altera, you've got the signal tap. Have you ever used signal tap before?
No, not yet.
Okay, well, it's invaluable. So that's another thing, to build a simple circuit and then fire up signal tap. And what it is this logic analyzer that goes in an unused area of the FPGA that allows you to connect up to existing signals and display them graphically, just like a hardware logic analyzer, and it runs over JTAG. So if you have the Byte Blaster on there, then the Quartus tool will, its subsidiary program, the signal tap graphical user interface, will allow you to look at things and probe things. And it's amazingly useful. You can find information out that you'd never be able to find it any other way without running extensive simulations. So it's a cool tool, and it's built into Quartus.
So, Scotty, can I jump in here with a similar question? So in the data engine that we're building, and how are we going to trigger the bootloader code in your design versus HPSDR, which had a hardware jumper?
In other words, to make it come up into the bootloader mode?
Right.
Well, what we can do in the Macs is, since we have 2 images,
right,
and we have an image that will contain the bootloader that's separate from our runtime image, what we'll do is we can have the command over the Ethernet say, go to the other image. We can actually command it to go to whichever image we want.
Okay. What I need to know is what kind of command from external, not from Quartus, but from an external signal, can cause that command to flip.
If you want to cause it to boot a particular way, you can hook up to the configuration select jumper. But if you're running one thing, like say you're running the code, the real code, and you want to reprogram it, so they call it RSU, remote system upgrade. So what we could do is we could put a hardware pin on the part that you pull down. Like for instance, we've actually done this with a TXD line from a serial port. So say you have an external something that has a serial port that communicates with the FPGA. Normally that port would be not used, right? It would sit idle. So the TXD line would sit high. And then what you do is, as soon as you see a transition on the TXD line, you say, oh, go to the bootloader, and you switch over.
So you do have that available in your design for the data engine, right?
It's available on any design if you can.
I just wanted to make sure we don't start building them before we have that.
Yeah, well, like I said, this last one I worked on where they added the remote system upgrade capability later, it was kind of like there all along as a requirement, but they never really got down to actually implementing it. And they built a whole bunch of boards.
Okay.
And then come to find out that the configuration select pin was left floating on all their boards.
Yes.
And so I thought, well, no problem. We'll just turn that off because I have the option to not in user mode to not use the config select pin. Okay.
Yes.
But what they don't tell you that you have to go dig down deep in the documentation is in programming mode, in initialization mode, it's always active.
Yes.
So you can't just say, oh, I'm going to let it float and then expect to get a particular image.
Right.
So what they have to do, and this is really hokey, but what they have to do is they had to boot up, and then since they don't know which image they're going to get because the pin's floating, you might get one or the other. If they come up into boot mode, they have a way to look and see if certain things have been initialized, and if they haven't, they say, oh, we're in there wrong, and then they switch to the other.
Yes. Okay.
So they actually load one and then exit that and load the other one. So it takes twice as long in the boot mode, but booting up is only microseconds anyway.
Yes.
I mean, hundreds of microseconds, but or a couple of milliseconds. So it really is not even noticeable, but it's just a hokey way to do things instead of going where you want to go.
Well, I've been going through, building a simulator, but that also makes me think about each of the steps that we have to go through to put images in and confirm them. And I'm thinking about the differences between our current board and all the HPSDR boards.
Well, this is good.
Have a hardware switch, as you know. It's basically a jumper.
I have 7 jumpers on the board that can be used for anything you want, although they don't go into any kind of hardware. I mean, there's just something you can read.
Okay.
So you can read it and say, oh, you want a bootload. Okay. And then switch.
I think it'd probably be better the first option where you pull something, a signal line.
What would you think we'd be using externally to do that?
I don't know.
Just like a computer serial.
Well, essentially, I have to get the hardware in a situation to receive the bytes.
Okay.
And then I start stuffing packets at it.
But you're going to do that via Ethernet, right?
Right.
So, yeah, so basically you just got to be able to switch to bootloader mode via Ethernet.
Right.
And how do you do the way you do it in HPSDR is you just load an area of the ROM that is not used.
So
how do you switch it then?
It's divided into, the whole ROM is divided in half.
Right.
And the base address is 0, and the other address is 1 million. So if the jumper is on, it starts at 0. Are you still there?
Yeah, I'm here.
And if the jumper's off, it automatically starts at 1 million and runs from above that.
But the question is, how does it do that? Because that's not an automatic feature of the part.
No, it's in the FPGA code.
So, but the FPGA code, because I think this is on Hermes, the FPGA code always boots to a particular address.
Yes.
And then you can read the data, you can read the jumper, and then you can reboot to a new address if you want.
Right.
So that's how it works, right?
So basically, when you turn it on, you either have to have the jumper on or off. And when it boots up, that tells it which part of the memory to look in. And you can't switch live.
Right.
You have to
reboot.
physically turn it off and then switch it and then turn it on again.
But that's what that implies is that you always boot into a particular area of the ROM.
Right.
And then that code has logic in it that looks at the jumper and says, should I stay here or should I go to the other one?
No, it actually uses the jumper to decide.
Well, yeah, but it's got to use some logic to decide, and it can't have any logic until it's booted. So, because there's no external logic.
So there would be logic in there to say, well, if it's off, I'm starting up at 1 million address
Okay,
1
so
million.
that logic would be in the bootloader code?
No.
Because if you have the
Probably,
bootloader
yes.
code, then you probably can't talk to your Ethernet software.
You can't talk, well, you can talk to the Ethernet, but you can't talk to any of the RF parts.
Well, you can't program the board
Right.
by Ethernet, right? Okay. Because I know
So
there's
you
actually
can send all the data by Ethernet.
right,
And this is all to avoid having to use Quartus for everybody.
right, but is that code in the release code or is that in the separate boot area?
It's in the boot area.
Right. So if you don't have the bootloader, if you erased it for some reason,
If you erase it, you have to go back to Quartus and put a new bootloader back in.
but you can still run the radio. You just can't go and
Oh
record it.
yeah, and you can actually program the radio in 0, and it works, but you just can't upgrade it.
Yeah. And because there's actually an output pin on the FPGA that causes a reconfiguration to happen.
Right.
And that's the thing that they did on the Cyclone part.
It was a Cyclone. Well, Metis is 3, Hermes is 4, and everything else is 4. All the other Apache boards are all Cyclone 4s.
Yeah, and that's why the Max is a little bit different than the Cyclone 4s or 5s.
Right. Right.
Because they have the internal ROM, and then they have they have a hardware state machine, so that if the image A is corrupted, it'll automatically flip over and load the other image. So
just at some point we need to sit down and write down exactly how this is going to work.
Yep. Yes.
I'm trying to write
pretty soon, actually.
Yes, I'm trying to write steps from my side in the code of what I'm doing, and I'm trying to pay attention to where I need to ask you specific things that have to happen in the FPGA.
Because what would be good is to be able to load a block of data, like 256 bytes,
right,
and then ACK that.
Yes.
Rather than, and so put a checksum across the block,
yes,
and then ACK each one. Because my philosophy is that the only thing that doesn't get ACKed is the stream of data.
Right.
Every command, every programming command, they all have to be ACKed by us. Not
right.
a TCP/IP triple back and forth, but just an ACK back. And even
yes.
So that if you set one and it got an ACK, then you could send it again.
And that's the way Hermes or the protocol 2 does acknowledge every packet.
Okay, but it doesn't have a checksum, right?
But originally, protocol 1 did not acknowledge packets. You just sent them, and if at the end, if it didn't work, it didn't work.
But on protocol 2, is each packet protected with a checksum?
No, but it's acknowledged.
But you're acknowledging what?
Well, in protocol 2, there is not a checksum. It's a sum. They just sum the packet.
Okay.
So it's a poor check on errors.
Okay, but there is some kind of error checking. So if it didn't work, then you'd have some.
It's a very simplistic version. Okay. But I've been spending a lot of time reading CRC 32. There is a variation of CRC 32 in GNU Radio. So, I mean, there's a lot of reasons why we should use that.
Yeah, and CRC 32 is just a bunch of XORs, right?
It's basically a polynomial equation that you run over the binary data, and the remainder is what you send.
Right.
And there's a polynomial, a base polynomial that you declare, and there's like 3 or 4 common ones, or you can make your own, but it's probably better to use a common one.
But again, this is just, I mean, from a hardware standpoint, this is just taking the incoming data and XORing selected bits into the sum or the checksum,
right?
And then accumulating that, and then
right, and then inside the hardware, you run the same thing. And I sent you a CRC 32 Verilog code in an email.
Okay. Yeah, I haven't had a chance to look at it, but
yeah,
I think if it's just XORs, it's trivially easy to run fast.
Yes. So I just wanted to give you, I know you like to have an example to start from.
It makes it much easier, yes.
Yes.
Dave, one of the things that's, I think is going to be a little bit different about our FPGA loads here is in OpenHPSDR, we basically had one load per module. There may be there were updates that would come along with that load, but they were all from the same basic tree. And I think in this project, we may get to the point where we're going to have different loads because we're going to be doing different things. Do you have any placeholders or way in the data set so that you know which kind of load plus also the revision that is existing on the DE?
Well, the discovery packet should give some of that. We've got a version number, a protocol, and protocol doesn't really mean anything to us other than what we make it mean.
Okay.
But we need to have in the code, the Verilog code itself, an embedded revision and embedded type, and the things that you can read to say, oh, I'm a VNA, oh, I'm a VLF receiver, oh, I'm a PSWS, right? Well, get that, Tom, right?
Right, and we may do some dedicated signal processing in the FPGA for some applications, but not want it there for other applications. Right, and so I see this becoming a tree with a lot of branches.
Yes, I don't see a problem with that. I see the big problem. So when you do a discovery packet, it should reply what's loaded in the FPGA at this time. And then if you want to load something else, you just go through a reprogram.
And you know, I can see how we might have standard supported versions, and then we'd have part of the field would say custom. And then the custom would have extension bytes that you could then pick for your own and say, okay, I'm going to be custom hardware 37, and if you get popular enough people will want that load that they'll be able to go and select that.
Yeah, so right now Discovery will report back the revision number in the Discovery response packet. Yes. But it doesn't say anything about what kind of load it is.
No, but we like you said, we have a lot of bits. There's a whole bunch of padding zeros that we could use.
All right, it's just something to put on the to-do list, I guess.
Well, I've been working on a document. I'm going to share it with you, Tom.
Okay.
Of what I'm doing. And that's just, I'm going back through stuff. I haven't worked on this since early 2000s. So it's like refreshing my memory of how it all worked.
But so really, Tom, it's like querying the board to see what capabilities the RF boards have.
Yes.
I mean, it's a similar thing. It's not the same thing, but it's like, I want to query the capabilities of this board. And part of that capability is what's loaded in the FPGA, right? What's the, and so theoretically, we should have a lot of slots available to.
Right. So we have kind of a two-dimensional configuration here. We have what boards are plugged into which connectors, and then we have the what software is or firmware or FPGA code is loaded into the data engine, because even with identical hardware capabilities, we could have quite widely different.
Right, and it makes sense for all the different kinds of design ideas we have that we need something much more flexible.
Yeah. Okay.
You know, there are a pair of bicolor LEDs next to each RF module, and they will, so you'll be able to, the FPGA code will be able to read the ID of each module and say, do I know what that module is? Or do I not know what that module is? Do I know how to talk to it? If I don't, red light, and then that means the user has to go do something. Or green light says, I got everything plugged together and I understand that board and I can talk to it.
Right.
And I don't really think, I didn't do that for the leaf or for the clock module, although they do have ROMs on them. Because the leaf has a ROM because it's a Raspberry Pi ROM. And the clock module, we're going to put an ID ROM on it just the same as we have on the RF modules. So you'll be able to tell what kind of clock module it is that you got plugged in.
Okay. Yeah, good. I just wanted to make sure we took care of both of those.
Yeah.
Sounds like you're on it.
The easy part is to connect the ROMs up. The hard part is to decide what to put in them to identify what everything is and to document it.
So,
go ahead.
all I was going to say is right now I'm focusing not on the actual code to make the radio work, but the code to program. So that's where I'm putting my effort for the next couple months.
Okay.
And Tom, did you see the document I sent out to you and John on the clock module for the pinout definition?
I looked at it briefly. I don't understand the clock well enough to make a good comment.
Well, what I want to do is I'd like to have a table like that for the RF modules and for the data for the leaf module, and incorporate that into the ICDs of those boards.
Okay. So the ICDs for the receivers have all the pins defined.
Right, but I want to put that table in there that describes which ones can be programmed, which ones should be fixed, and what levels they are, and more of a description of each pin.
Okay, that
Can we do that?
I'll look at it. I thought all that was already in the receiver. It already gives you the direction, whether it's bidirectional or single-ended, the voltage, all of that's in the receiver ICD.
But the bidirectional pins can be programmed to be monodirectional if you want them, unidirectional.
Okay, I'll try to look at the document and see what additional information I can figure out from it and add that to the receiver.
It seems like it's going to be very complex to describe what all these pins can do, because since the FPGA can program them either direction, open collector, LVDS, or whatever, we have to be able to tell the users, well, which pins are those? Which pins are paired together? Which pins are not programmable as I/O? Well, they're all programmable as I/O, but there are some restrictions on, like on the I2C, where we say the ones reading the ID they're like separate dedicated pins. So you can't reprogram those because the FPGA needs those to go read the ID-ROM to figure out what the board does. So to figure out which way to set its pins, if you will, because I'm envisioning that the pinout table could be in the ROM. So we could, when the FPGA goes and reads the ROM, it could set the IO pins. You can't set the voltage level, but it can set the direction and the type.
Okay, well, yeah, I'll look at that clock module document and see if I can figure out what you're looking for. If I can't, I'll just send you a simple email that just says help.
Okay, and I can send you that document's done in Word, right?
Yes, yeah, I think most of them are done in Word.
So if I could send you the paragraphs describing the pins, if that would be helpful for you to incorporate, if you could tell me what would be good.
Okay, I'll look at it and noodle for a while, and I can send you the Word documents for the receiver, whatever you need.
Probably most important for the leaf and the, well, I don't know who else is going to be designing boards. Already we have Jonathan's going to be doing a leaf board, so it's important for me to get a document like that to him, which is what I need to work on next. So, but anyway, because the interface is very flexible, but it does have its limitations. Like IO voltages, you have to move all the IO voltages and the bidirectional pins all at once. You can't have some 1.8 and some 3.3. So maybe a limitation.
Well, you answered what I needed to know, although I'll have to spend more time asking questions. I think the three of us will have some, and I'm sure John will get in. Oh, by the way, I saw your talk with John, and it was good.
Oh, okay. At Hamcation, when we did
Yes.
Hamcation. Yeah, it was kind of like a turbo talk. That was like, I think I had 23 slides and I had 10 minutes. So
yeah, that sounds
familiar,
Scotty.
Did it sound too rushed, or was it okay?
And I did have fun trying to get my head around Michelle's talk. So
yeah,
it made sense, but I have to think about it some more.
I especially like the what is it, the yo-yo rolling up,
or the fishing reel.
The fishing reel. That was brilliant.
So the reel is basically your phase.
Yeah.
And that's a clever way to explain it.
It is.
So now, whether people really understand it, I don't know,
No.
but
I think you have to explain it all different ways, and sooner or later one's going to go click, and then
well,
you get it.
It makes a lot more sense when you already know what she's talking about.
Yeah, okay, I guess that's true. Yeah. Too many late nights, I think.
Yeah.
I was actually watching a video by on Milton Friedman. You know who that is?
Yes.
And they were talking about when they would take their retreat up to the country, up to New England, and they said there was no electricity, so they would read by kerosene lamp. And they were both night people, so they would stay up till 3, 4 in the morning, and then they sleep till noon, and then they get up and I'm going like, that sounds really familiar. Because there's more to be done, so you just keep working. I mean,
yeah. Well, and it's quiet at night.
It's quiet.
Yeah.
Even the cat goes to sleep.
Yes. So I don't know.
If I could just interject something, one thing I hate about all these boards is this use of bicolor LEDs, because I'm red-green colorblind, and when people say, "Well, what color is the LED?" I go, "I don't know, it's red, green, something like that." So a difference that if it's flashing, you can tell flashing and solid, or that stuff, but a red or a green is impossible for
what we could do for you is we could make good the green on and bad flashing alternately. You could detect that, right? Because they're physically separated from each other by a slight amount.
I could probably tell that,
but
but
if I answer is turn it off in between, then you could see it would be green off, red off, green off. So you could see it would look flashing to you, right? So that
yes.
You can tell anyway. Well, I know we had a color chart for the grape. John sent me a chart with color-coded pinout, and I go, first of all, I'm not colorblind, but I don't do really well with shades of color that are close together. So, like light purple and dark purple, I don't, and he had like 8 different colors, and you try to pick 8 different ones that you could distinguish. So I put a column in there with the pin numbers so that you don't really have to see any colors at all. You can just look at the pin numbers and figure it out. So yeah, well, that's a good comment for us to make sure we put that in the code to do that. It's just that these LEDs, they're 0603 packages and they got 2 LEDs in them. How can you resist not using a part like that? I mean, they know it's an 0603 part, right? That's like 60 thousandths by 30 thousandths, and it's got 4 pins on it. The core corners are the 2 different LEDs. It's like, wow. Okay. And the green ones alone they're 0402s, so they're fun already. But to have a bicolor like that, how could you not use it? And my CAD guy was lecturing me today about using those small BGA voltage regulator chips. He says, you use some of those parts you use, you're going to restrict who can build this board for you. So, well taken. But we're going to use the biggest parts we can use that fit on the board. And if we need space, we're just going to go to the smaller parts because I don't want to make the board bigger.
Mm-hmm.
I think that's, but on the other hand, I don't want to raise the cost of the assembly either. So, and actually, I'm not really that concerned about the cost as I am concerned about places that just won't be able to do it. They'll say they can, but then they'll build the board and they'll get, 50% yield because they can't, the technology is beyond them. So, SOICs are really easy. You can actually see the legs on them. So, but they're still too small for me to put wires on. So I have a question for Nathaniel. If your question's answered.
Yeah,
Dave.
I think mine's done.
Do we have any posters that we can export to like a PDF version of that are to talk about space weather science type focus rather than engineering? Because I don't have all my stuff's in radio engineering. All I have is the presentations you've made with some slides, but it's not really a poster.
A poster. Let's see.
The posters aren't all restricted.
Well, we have
that software that you were using, are they?
What's that?
So like for the so when you build a poster using that software for the conference that you just had, what was it, a couple of weeks ago? Are you able
at
to
AGU?
Yeah.
Yeah, that doesn't export well to a PDF. Like you can print it to like almost a paper, so you can get a paper out of it, but you don't get like a nice poster PDF like I think you're looking for.
Yeah, and I think that's what I am
trying to think of. Yeah. I don't know that we have a nice one. We have the one that Christina did for AGU like 2 years ago, but I think that's still more of an engineering poster than a space weather
Well,
one.
it would be okay. I mean, engineering is okay, but I think the focus I'm looking for is more the space weather science aspect. You know, what is space weather?
Yeah.
Why do we want to measure it? What effect does it have on us? That kind of thing.
It's like a very generic overview poster.
Yeah, because I was asked if we have a Tangerine poster, and I had to admit that we don't. So, not yet anyway.
Yeah, I don't have one. I don't know that. You need it by like the 13th.
Yeah, I need one by the 1st of March.
By the 1st of March.
This is a different show. This is well, actually, it's the
And you want an actual paper one?
It's no. I want a PDF one, and I've got I got someone to help me work on the PDF who has Adobe, the full end Adobe, who can do embed videos and PDFs and things like that. But I've got to get content, and I don't have any. I could provide content for the Tangerine, but for the science one, not so much. So even if I had one that I could look at and copy, you know, that would work.
Let's
Tornado
see.
up there.
Yeah, I'm trying to think if there's anyone who could kind of do this. I am like so booked myself right now that I just
I don't want to impact your scheduling.
I know where you can get comic books. Space weather comic books. I'm serious. There's a whole series of
even
space
like
weather
the one
comic
Christina did would be good.
Yeah, I mean I can send you that. I also have a one I did of the solar eclipse QSO party. And I mean if you're looking for content, I mean I can send you the links of the ones from AGU that were virtual, and then you can, you know, work with that content.
Can I get download the images from somewhere? Do you have the images that you used to make those, or whoever made them?
It depends. You'd have to contact the author of the poster. So for mine, I do. But like for Christina's or Diego's, you email them.
Yeah.
Yeah.
Okay, because that's kind of what I'm looking for. And I know it's kind of short notice, but I think the
why don't you work with? I have I've given lots of talks. Why don't you pull stuff out of my talks?
I could do that. I could pull the images out of there because a lot of those images are in your talks. Yeah. Okay.
Yeah. Yeah. I mean, I just gave that talk at Propagation Summit. That's got lots of great stuff in it.
I just thought maybe you had some posters pre-made, but if they were made using the special software, they're not really going to be able to be exported, right? I mean, you have to really, they're for that event that the software was licensed for, right?
Yeah, well, I'll tell you the way you export it. You basically print it out into a PDF. I can show you.
But then, like embedded videos are gone when you do that, right?
That's right. Yeah.
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 And actually, I'm not sure embedded videos. The kind of embedded video I want will be like the video of the Doppler shift for WWV, you know, like a 30-second clip condensed, a 24-hour condensed into 30 seconds, showing how it's kind of like an animation. Because the embedded
you should
video,
email Christina.
Okay.
She has that video. She'll be able to give that to you.
Because embedded videos to me should be maybe 15 to 30 seconds long, and then if you got a longer one like a presentation, you should just put a link to it on the poster.
Right. Yeah. Here, this is. I will share this talk with you.
Because we actually have an opportunity to share a booth at Ham Expo and put something up there. We don't have a booth, but we're being offered space, so I don't want to turn that down if I can help it.
No, yeah.
So no talks. The talks are all booked, but the posters are up in the booths, virtual
posters
booths.
are good.
Yeah.
Yeah, I just sent you a Google Drive link with the talk. It says for the Embry-Riddle Space Science Group. It's basically the same talk I gave for the propagation summit.
Okay. So it's a PowerPoint, or what is it?
Yeah, it's a PowerPoint. It's a couple embedded movies in it.
Well, I got one that there's no way I'm going to open that.
You have to download it.
It's from tmomail.net. That's not you, right?
Yep. No, mine should be coming from Google Drive with Virginia Tech. It should be from Frizzell at vt.edu via Google Drive.
Okay, this is a link to a YouTube video about gravity and time with 4 attachments that I will definitely not open because
no, that would not be the one.
Looks not like it's from anybody that I know.
Or here, I can also just send it directly to you in the chat here. There.
Okay.
Do I have audio now?
Yes.
Yes, you do.
Okay, thanks. W7LUX.
Did you want
Hello,
to make
Joe.
a comment since you didn't get on in the main session? If you want to make any comments, Joe, feel free.
Oh, I'm brand new with this and just wanted to see what was going on and offer help if any of my past experience would be that. I've got pretty fair amount of experience in precision timing and frequency.
Okay, good. Well, we're going to have a fancy timing
nice.
board that's going to need tweaking. So it's beyond my pay grade too, that all the timing stuff. Do you know John Ackerman?
I do not.
He's a member of the Time Nuts group, and I always joke with him because he's got like 2 rubidium standards in his basement, and I told him, you know, a ham with 1 clock knows what time it is, but a ham with 2 clocks is never quite sure.
So I probably have 3.
Oh,
not really. I only have 1 rubidium, but I've got a pretty darn good
I think your audio cut out there.
1, 2, 3. Okay. I have 1 rubidium, but it's a very small one. But I've got a good GPS DO.
Oh, okay.
Both of you are in Arizona.
I am Flagstaff, Northern Arizona.
You're in Stafford?
Say again?
Where did you say you were?
I'm in Flagstaff.
On Flag, okay. I'm in Tempe, so.
Oh, okay.
That's about 130 miles away, Nathaniel.
Ah.
So you must be getting some good weather up there, Joe.
It's been okay. We had some wind, but we did get some snow, and it took a while to dig out from somewhere between 30 and 40 inches of snow, but nothing like what happened to my brother in Austin, Texas.
Oh, yeah.
Well,
So
Scotty, I'm starting to fade a little bit here.
Okay, I got the download, I think. So Embry-Riddle are there more branches of Embry-Riddle than the one here in Arizona?
There's one down in Florida.
Okay.
That's the one I spoke to.
Okay.
Yeah, it's in Daytona.
My friend Kshitija is the professor there.
Okay, I'm just saving it here now, so. Okay, 183 megabytes, not bad.
There's a lot of little moves in there.
And there's lots of pictures, or let's see.
Lots of pictures, little movies. There's some audio.
Oh, I hate this. I put it on the computer. Oh, there it is. I was going to say, I lost the directory that I made. I hate it when that happens. You know, back when you had only 5-minute hard drives, you didn't have this problem.
I know.
Okay, well.
Back in the day when everything was on core memory.
Yes. Yeah, we had the computer that I learned on had 16K of core memory. 16K words,
Wow.
so it was 16-bit words.
Wow.
It was a germanium transistor-based mini computer.
Whoa.
And everybody else ran the simulator, and I like to use real hardware, so I would run the real computer. That was
Who was the manufacturer of that computer, Scotty?
It was called a Data 620, and I think it was just called Data Corporation. It was built in 1968, I think, and it was like a 19-inch rack, 7 feet tall and 2 feet deep. Heavily modified by the students in the EE department. And I still remember my professor was railing. He hated CMOS logic. And this is right about the time CMOS was starting to get fast enough to be actually considered as a real viable alternative. Well, he had a student who used a 1 of 4 decoder, CMOS decoder, to select the memory banks. The delay through the decoder was 1,000 nanoseconds. It was an entire microsecond. And even for core memory, that was pretty slow. So he was railing against CMOS. And I just remember all the stuff I'm doing in my home lab, right, is all CMOS. And he's saying, oh, that CMOS stuff is no good. It's too slow. Oh, that's terrible. And I just had to go, keep my mouth shut, because this was the guy that I told you. I don't know if I told you this, but first day of class, right? Student raises his hand. He asked the question, and the professor, I kid you not, the professor says, well, that's a really stupid question. No more questions the rest of the semester from anyone. After he did that, he just shut everybody off. And I think he did it on purpose. so he wouldn't have to deal with questions. So he was a cranky old. You could tell he knew his stuff, but he was not really a good professor, in my opinion, because he didn't really. He looked like he'd rather be somewhere else. So it's too bad.
Didn't have the heart of a teacher.
Didn't have the heart of a teacher. But we gave him a hard time though. So he
Are we
deserved.
about done here?
Yeah, we're done.
Nathaniel needs to be excused. He's about to fall off his chair.
Yeah.
There. We're still
You
getting
hit your
late.
head on the keyboard. You know.
Does it look that bad?
I could tell you're falling asleep. So let's go QRT. We'll get together next night.
We're way over anyway. So, but it was a great session.
Thank you, everyone.
Stay warm back there, everyone.
We'll try. You too, Scotty. Bye, Veronica.
Bye.
Bye,
everyone.
Bye, everyone.
Jonathan, Bill, Mike, Yeoman.
You want to leave this on, Nathaniel?
Yeah, you're gonna become the host.
Oh boy.
Have fun.
So, are you there, Dan?
Yes, I am.
So, how's the weather out there? Is it still cold and ugly?
Still chilly, but it's supposed to be 60 tomorrow.
It's supposed to be 80 here by the weekend.
Yeah, it's going to get up into the 70s, I think, next week. So winter should be over when that happens.
Oh, come on. It's only February. Winter can't be over.
No, it's actually about the middle of March is when winter ends here. So we should be in pretty good shape from now on. I mean, the last couple of weeks was really an aberration.
Well, I just looked at the weather. 80 tomorrow, 80 Wednesday, and we're gonna have a cold wave. It's gonna be 71 on Thursday.
Oh, that's nice. I lived in Arizona 14 years, 15 years, something like that.
Yeah.
So I remember it well.
Yeah, the erratic weather, as they say. Well, we got to see what time is this? 8:30 here. We're getting our vaccines tonight.
Yeah.
About 2.5 hours is when we get them.
All right. So do you know which one you're getting?
I think it's Pfizer. I'm not sure.
Okay.
They won't tell you until you show up.
Oh. Well, they don't want to scare you off?
I don't know. I don't think they know.
No.
They're going to give you whatever they have.
It's 3 weeks for Pfizer, right?
3 or 4, I thought.
One of them is 4, one of them is 3. I thought Pfizer was 3 and Moderna was 4.
Well, they're supposed to give us our second appointment when we show up tonight.
Oh, yeah,
so,
yeah.
I had the Moderna and it was 4 weeks.
It was 4 weeks? I think Pfizer is 3 then.
Right, Pfizer is 3. And the people generally have a little bit more reaction with the Pfizer than with the Moderna.
Yeah. But I hear that the Moderna is a little bit more effective, perhaps, against the variants, the mutations.
I sure hope so.
But they just, I think
that's
they're all
a supposition.
They're all just guessing. Yeah, so I don't know what we're going to get, but one suggestion was that we get the shots in opposite arms.
Really?
Because you get less of a reaction that way, is what I was told. Now I don't know if that's just baloney or what, but that's what a girlfriend of Nona's said. She got hers one on the left and one on the right, and it was much better than getting them both in the same arm, even though they're 3 or 4 weeks apart.
My arm was pretty sore for both of them.
So did you get any other reaction besides just the soreness?
The first one, I had a very mild rash. For 2 days, I had a very mild headache and felt just kind of tired for the first one. Second one, sore arm.
Okay. Well, the thing is that I had COVID in December, so I don't know if I'll have any reaction at all with this, because I supposedly still have some natural immunity, but who knows how long that lasts.
I don't think anybody does.
Yeah. And you know, you tell them you had COVID and is that an effect, and they don't know anything. They don't know whether it will be a problem or not. So, but I
Well,
do know what they said was after you get the shot, you have to pull out into the waiting area, and they have to observe you for 15 minutes.
right, unless you have a serious reaction to something else, and then it's a half an hour.
Oh, okay. Because I know when they said when they give you the injection, they have a nurse standing by with a syringe
Yeah,
of
EpiPen.
antihistamine, right? Epinephrine or whatever it is, right? Did they do that to you too?
I didn't have any problem. We had people standing around. Yes, I had mine done at the VA.
Okay. Yeah, we're going to the parking lot of the uh, the stadium.
Yeah, up here it's the parking lot over at the amphitheater by the county fairgrounds. That's where
Yep.
the girlfriend went.
Okay.
She's an NP, and the reaction can range from a sore arm to one of her coworkers ended up in bed for 36 hours.
Oh wow. Well, I already had the COVID, and I was in bed for longer than 36 hours, but it really wasn't. The regular flu was much more severe for me than this was. The worst part of it was is laying there wondering if you were going to be one of the ones that dies and, and not, or not.
That could kind of temper your outlook on things.
It does.
Fortunately, obviously, you're still here.
Yeah, yeah. Yeah, like I said, it wasn't really bad. It was long and it was just irritating, and it just made you feel like you just wanted to lay around and do nothing, which is what I pretty much did because, and you know, when I can't sit up in front of the computer, it's pretty serious.
Yeah.
But you just feel bad. That's the only way I can describe it.
The girlfriend is a NP, and she's at a mental health facility. And a number of the staff members have had it. They say you do not want to get it.
Yeah.
These are generally younger people.
So they've had some reactions too, even though they're younger.
They actually have the disease.
Yeah, well, that's what I had, and I'm old enough to be in the group that doesn't want to get it.
Oh, well, me too. But yeah, the younger ones, some of them had pretty bad reaction, and they were pretty sick in bed for several days at least.
Yeah, well, it was definitely was bedridden. I had a fever for 4 or 5 days, low grade, just 101, 100 and a half, 101, but it was enough to knock you down. The thing that was good about it was I didn't have the respiratory reaction that I had with the regular flu.
Well, that's what gets people. Wow.
I know, isn't that weird?
That you're still here talking to me.
Yeah, and it's like, I had hardly any cough. I had no congestion. I had none of that. I had a headache and aches. That's what was most of it.
Wow. Well, you were, I think, fortunate.
So that's pretty lucky, yeah.
Well, the symptoms range everything from feeling kind of crummy to death.
Yeah, not being able to breathe.
Yeah, that's what happens with the doggone that flu that hit us back in 1918.
Yeah, yeah. Well, they said that I read a lot about that. They said that it was the immune system that killed the people, and it was the young, healthy people that were by and large the quick victims of it. And they said sometimes it would hit them and they would kill them in one day.
We have something endemic around the Four Corners area, Hunta virus.
Oh, yeah.
That'll kill you in a day or two. And same type thing. It's a total, what do they call it, a cyclonic immune system storm, and your lung fills up with fluid, and you're no longer alive.
Wow. And it's spread by like field mice and
those
right?
little deer mice.
Yeah.
We had a big to do at work to get rid of all the mice.
Is there no vaccine or cure for that either?
I have not heard of one, and it's relatively unusual. You've got to actually catch it by going out and cleaning up where mice have left all sorts of bad traces and things.
Yeah, it's spread by urine and feces of the mice, right? So
Correct.
like they get in your trailer and you go in there to clean it up, then that's when you catch it.
Yeah, and it's a pretty high fatality rate.
Ooh.
It's at least 50%, and probably more like 70 or 80.
Well, that's pretty bad. Yeah, considering that a bad fatal disease, I mean, a fatalistic disease is like 10%. And I was reading up about the plagues of like 750 or 800 AD, 1350 AD, and there was another one in the 1800s, believe it or not, of plague. And they said there are three kinds of plague. There's bubonic plague, there's pneumonic plague, and there's systemic plague. And they said bubonic plague, I don't know, is like 50%, 40 or 50% fatal. The pneumonic plague is like 80% fatal, and the systemic plague is like 98% fatal. The
What is
systemic
the
plague
third one you mentioned?
it's systemic plague where it gets in your blood.
Oh, okay. Ouch.
And it's much rarer, but because it's harder to transmit it.
Septicemic.
Septicemic, that's the one. Yeah, and it kills you fast and good.
There's a sci-fi yarn by a gal named Connie Willis or something, and it has to do with a modern person going back in time and living through that plague. And she did a lot of research on it. Yeah, it's pretty ugly.
Yeah. Even the bubonic one is bad enough, but yeah, because they said the bubonic infects the lymph system, pneumonic affects the respiratory system, and the septicemic infects the blood circulation system. So,
and you better get antibiotics right away, is all I can say.
Well,
Fortunately, it's not all that common. But when I was over at University of New Mexico, we had a problem where some hippie from the commune up north of town came down with it. And how did he get it? Intimate relation with a dead rodent.
Oh, please. Really? Don't you deserve it if you do things like that?
It's kind of my thought.
Oh, geez. I mean, there's risky behavior and then there's aberrant behavior.
I've got a fair amount of test equipment for doing timing and stuff like that. So if you need anything, I probably have time to 5 or 10 nanoseconds. And if you need anything like that, let me know. W7LUX@ARRL.net.
Oh, okay. And do you have any way to measure like low phase noise levels?
Phase noise, I'm not very good at that.
Okay, yeah, the equipment's difficult because most of the equipment has equivalent phase noise to the thing you're trying to measure, so it makes it really hard to. And I think
my job had to do with frequency and precision timing. I worked for the Naval Observatory.
Oh, okay. How long ago did you see was that in Annapolis or where were you at?
Flagstaff. We have a remote station up here at Flagstaff.
Okay.
And yeah, I did the timing for them at the station. We monitored the Loran stations to keep them on frequency.
Okay. Very good. Well, I'm not really a frequency expert. I turned most of that over to John Ackerman. And again, we're modular. So we have the clock module, which is a GPS-DO module that plugs into the Tangerine, to the data engine. And then we have the RF module, which also plug in. There's two RF modules, two slots. So you can plug in two RF boards, the same ones or different ones. Right now we only have one board, which is an HF board, which is like 100 kilohertz to 60 megahertz. But John is Jonathan Rizzo. I don't know if he's still here. He's still logged in here, but he's working on a VLF module that will plug in to the what we call the leaf slot, which is basically a Raspberry Pi extender, a hat, but it's enhanced hat because it's got some high-speed I/O that goes in as well as the regular Raspberry Pi header. And he's working on a VLF board because he wants to do lightning measurements, lightning detection, and not just detection but measurements. So
I've got a Blitzertongue system running here.
I don't know what that is.
Oh, it's a European design lightning detector system, And if you do blitzer tongue or something like that, or blitzer tongue lightning, it'll give you a map of where all the lightning strikes are happening in the world. They've
Oh,
got
okay, I have seen that. I have seen that. Yeah. So
But
you got set up
really,
at your place?
I have one up in the attic, yes, or up, yeah, up above somewhere. And it's one reason I haven't put a metal roof on this place.
Yeah, yeah.
Joe, which system do you have? Do you have the blue or the red?
I have one of the older ones from about 5 or 6 or 7. It's not the new one. I think it's a red.
Okay.
Whatever was available 6, 7, 8 years ago, something like that.
Oh, all right. I'm still waiting for mine. I guess that they haven't made any new kits yet.
Mine is not as sensitive as some of the other ones. Plus, I'm surrounded by power lines, which doesn't help very much. But some days I outperform others, and some days I'm 4th or 5th down the queue.
So Jonathan, how's your new job?
Oh, well, it kind of started off a little slow. I didn't really have access to a lot of systems yet, so I couldn't really do much. I don't even have access to my timekeeping system yet, so I can't log in and put in my time for my contract. But I took a tour of the depot, and there's a lot of really nice areas. There's Navy, specialize in Army and Navy electronics. So there's tons of areas of people on benches working on the different stuff. There was this really cool Faraday cage type room where they did alignment of the Army and Navy radios. Just tons of awesome instruments and power supplies. It was awesome. So I'm pretty stoked about it. I don't really know exactly what I'll be working on yet because I don't have access to the systems, but I've been reading some instrumentation manuals and to kind of getting acclimated with what I need to do and my shift and everything else. But yeah, it's a lot of fun.
So are they just waiting for like a clearance, or what are they waiting for to give you access?
I'm not sure. I think, well, it's because I work for a contractor and not the government. I don't know what happened. I don't know if they just forgot about me or, but no, I don't have the because I do have a clearance, an interim clearance, and in about a month I'll have my full clearance, and but yeah, I don't even have access to log on to Windows yet.
Oh geez.
Which I thought that would all be taken care of, because they knew that I was starting, but.
Oh yeah, I know. I've worked places before where they know you're starting, but they actually don't do anything until you show up. So you've got to submit paperwork to get their work request in, and it just takes, everything seems to take forever.
Yeah, they're trying to get medical care up in Flagstaff.
Yeah, and the thing is with government work, there's a lot of bureaucracy and paperwork and this and that all has to go through. So, but I'm sure that I'll eventually get access to everything. I don't even have access to my benefits page or my 401k page yet. So, I'm sure that'll happen this week.
So did you just start today or last week?
I started today.
Okay, so it was your first day, so that's
Yeah, that's kind of normal, I guess, for a government contract type
yeah.
work. But yeah, it's a lot of fun. And my grandfather worked in the paint shop at that depot, and my uncle
Really?
also worked there. Yep.
Wow. So
Yeah.
anyway, I think we may end up have to run your F-Sync, B clock, and SD out pins on 1.8 volts, and I think that will work. If not, we have enough 3.3 volt pins that we can actually run it off of the Raspberry Pi connector.
Oh.
So what's going to happen is there's actually a direct clock from the GPSDO module to your board to the M.2 connector, and then there's a direct clock output from the M.2 into the FPGA. So what you would do is you would take that clock that you get from the data from the GPSDO,
yeah,
and you would buffer it, feed one output of your buffer, a 2 output buffer, one into your A to Ds, and then you send the other one out back to me. Okay, so that would mean you're clocking your chip and me at the same time, right?
Yeah.
And then it seems like all you really need, and so those clocks are all taken care of already. And then you really only need 4 pins. You need the F-Sync, B clock, and SD out, and the shutdown. And then, of course, the I2C pins, which we already have those also on the Raspberry Pi header. So I think we're covered, and we can make the F-Sync, B clock, and SD out. We can make them either 1.8 or 3.3, depending on where you connect them.
Okay. Well, if I use 1.8 volt IO VDD, what is the GPSDO clock at?
The GPSDO clock is it's settable. So actually, that's a good point. Wait a minute. See, I've got the schematic right here. You will be able to tell it what to run it at. So you, let's see if I can. That's a good question, because you need to be able to tell that clock what level to be. So yeah. I'm going to add a pin to the connector. It's a good thing that we talked about this, because the clock coming from the GPS, see if I did this, from the GPS module, you need to output the voltage level that you want to come back in, right?
Yeah.
So you said it, so basically the VCCIO clock is going to be an output from you that's going to go to the clock module, that because all of the outputs of the clock module are they're individually settable with their own VCCIO. So you basically can set it to whatever level you want. And I take it, does it mean, I was trying to figure this out, if we set VDDIO on the Cirrus part or on the TI part to 1.8, does that mean your clock is going to have to be 1.8 also?
Yeah.
Okay.
Can that be done?
It can be done. Yes.
Okay.
That's a good point, though. I'm going to have to fix that.
Yeah, because if you don't have any 3.3 volt left, then we'll just use 1.8 and that'll work fine.
And the thing is, it won't limit your speed, right? I mean, you still run it at the high sample rates at 1.8, because you'll be running the core at 3.3, right?
Right. Yeah. Yeah. The only thing that it changes is power dissipation. So the power dissipation will be a little lower at those high speeds.
Which actually is a good thing, I guess.
Well,
I would think it might be lower noise too, because you have a lower slew rate at 1.8 volts.
well, yeah, right, that's true. I think though that I would be susceptible to more noise at 1.8 volts. However, we could maybe we could use some ferrite beads or some series resistors to reduce the noise.
I think it's going to be point to point, and it's going to be an inch long trace, so it's going to be very, very short.
All right, then we probably don't have to worry about that. So then what I'll do is I will put the ADD converter pretty close to the M.2 connector to keep the traces as short as they can.
And we might want to either terminate them at the end or terminate them coming in, series terminate them coming in, or parallel terminate them. But it's not really going to be that fast. I mean, it seems like about 29 megahertz, or is it 29 or 49 megahertz? It's the fastest speed that you need.
49, I think.
Okay. So I'll give you an output to reset the VCCIO. The clock out to me is going to be at 3.3 volts.
So then I would have to use a level converter.
Right. Well, you're going to have to buffer it anyway. So that could be you'll level convert it as you buffer it.
Okay.
Let's see. So, okay, now wait a minute. So you're going to take the clock in, and it's going to go into the GPIO1, right? Because that's going to be the clock input.
Yep.
Yeah, that's going to be interesting. So, because I have to have a copy of that clock too, because I have to generate the F sync and B clock to you.
Right.
Yeah, I'm trying to think how this might work. They don't really have any dedicated clock inputs that are low voltage. Okay, let me think about that a little bit, because all of my inputs are 3.3 volt tolerant, but you're not going to be able to drive one of my 3.3 volt inputs with a 1.8 volt output. That's not going to work.
Right. Well, then what I can do is I could put a level converter on there.
Yeah, you could do that, but then you're going to end up with. I mean, I guess you could put two buffers, because you're gonna buffer it coming into the board.
Yeah.
At 1.8, and then drive it out to your chip at 1.8.
Right.
You're going to take it that same 1.8 coming into the board, and you're going to raise it up to 3.3 and then buffer it out to me.
Right. Right.
So the only problem will be, is there a difference in propagation delay between the level translated one and the non-level translated one? And probably there won't be much. But I'm thinking 50 megahertz is what? That's 25. Let's see, 100 megahertz is 10. So it's 25 nanoseconds, 20 nanoseconds. So that's pretty reasonable amount of time, I think.
Well, then I could probably look for a buffer with fairly low, some sort of propagation delay lower than 20 nanoseconds.
Yeah, the delay doesn't matter. It's the skew between the two outputs that matters.
Right. Yeah.
I mean, I don't know. The other alternative is that I'm going to have a clock coming from the clock module itself. And if we can program the synthesizer chip on the clock module to be synchronous, edge synchronous, same frequency and edge synchronous with the one you're getting, then you won't have to feed me a signal. I could just use that, but it's going to have to be synchronized. It's going to have to be the same frequency and the same phase.
Well, I thought that's what you were going to do originally. You were going to feed in a So the output from the clock module would feed both the FPGA and the A to D converter.
Yeah, no, they only go one place. The clock module outputs only are point to point. They're not multi-drop. But their outputs that come out of a Silicon Lab synthesizer chip. And so I think there's a provision to make those outputs basically identical if you want to.
Right.
So anyway, I think it's still better if you fed me the clock, because then you have control over it. So you don't leave it up to the clock module to do it, and whatever you need to do on board. Because I haven't looked at the timing yet, but I mean that clock is going to be what I'm going to base the F sync and B clock on, right?
Yeah.
So I don't know, because okay, so I'm going to provide you with F sync and B clock, and I'm going to get SD out, right?
Right.
Well, how does my F sync and B clock have to line up with that master clock? I know that the divider ratios have to be correct, for 128 clocks per, but I don't know whether it has to be phase aligned or not.
I believe it does.
Okay.
In fact, I'm almost certain that it does.
Well, I mean, the thing is, it will be, I guess it'll be phase offset by some slight amount depending on what your buffers do. But I don't think that matters as long as it's less than the clock, because the setup and hold times for the data that I'm going to get are going to be based upon the signals that I feed to you.
Yeah.
Not on that B clock, on that M clock or whatever it's called. So I'm not sure how the clock domains work, because you've got the clock coming into the part that's going to actually control the analog to digital conversions, right?
Yeah.
And then the F sync and B clock that come from me are going to control how the data gets clocked out on the SD out.
Yeah.
But obviously they're related, because every 128 of my clocks, of my B clock, it's going to have to be faster than M clock, right?
No, actually.
True. M clock gets divided down, doesn't it?
Yeah. So M clock is the fastest clock, and everything. And so what's important is that the M clock has to be synchronous with the B clock. That's the main thing.
Okay. But it can't be exactly synchronous, because I got to generate the B clock from M clock.
Yeah.
So there's going to be some delay there from M clock edge to the B clock edge if I'm going to have to. So my B clock output's going to be from a flip-flop that's going to be clocked by M clock, right? And then I'm going to decide how often B clock changes in relation to M clock, because M clock's going to be faster than B clock.
Right. Yeah.
So like every other one, every fourth one, every eighth one, whatever the ratio is, that's what my logic will do. But again, it's still got some delay from M clock edge.
Well, that might not be that much of an issue. I don't think that it's really going to be that much of an issue, as long as it's in phase. Even though there's some delay,
as long as the phase doesn't move, you mean? It's a fixed phase. Right. Let's see. I've got the data sheet is the TLV 320 ADC 6140, right?
Yep, yep.
So let's see what it says about clocking out. So we're going to run it in slave mode with an external M clock coming in on GPIO 1. And we're not going to use the PLL. Is that what you had said?
Right, yep.
Yeah, come on. Where's it? I know there are tiny diagrams in here. Let's see. You see, they show F sync and B clock and the output, but they don't ever show M clock relation to it. Just that you better have the right number of B clocks for the data that you're shifting out. Otherwise, you won't get it all shifted out before they do another A to D conversion.
Right.
And then you'll be in trouble.
Yeah.
And you're looking at 32-bit output, right?
Yep.
Well, you got B clock to F sync ratios, which are high, but those are easy to do. Wow. They don't really talk about slave mode in here much, do they?
No, I think that might be. Let's see. So if you look at page 117, it's the second link, configuring and operating as an audio bus master application. I believe that's the one that I was looking at.
Is it bus master? These are all ADC X14. Oh, I see. There's the family of 3 different ones. Okay. So that's the one as an audio bus master. And like I said, I thought we were using it as a slave.
I think it's called. It's not technically called slave mode. It's let's see.
Yeah, because this for I2S-based digital comms, the master device generates the bit clock and word clock, or F-sync. And we don't have a word clock. We have B clock and F-sync.
Right.
On the other hand, a slave device receives the clocks B clock and F-sync.
See, because I think.
So it says you can disable the PLL and derive all the clocks directly from M clock.
Right, right. That's what we'll be doing.
Okay. So we'll be using auto clock detect then.
Is that what it's called?
Yeah, I'm on that application note that you said, and I'm on page. You don't have any page numbers. Section 212.
Oh, right. Yep. Yep, that's it.
So this is interesting. It says for a 24 megahertz or 22 megahertz M clock, the following I2C script configures the TLV as master mode with GPIO1 as M clock input. How can it be a master if it's taking the M clock from somewhere else? That makes no sense.
You know, that was a little confusing, but they call it master mode. I don't know why. Other than, oh, maybe they mean slave mode, that it's operating as a slave, but but yeah, you're right. It doesn't really make sense. But I took master mode as the slave mode, because that's what Cirrus calls it. So if you generate the bit clock and the word clock, Cirrus calls it slave mode. Slave mode meaning if you have a more than one A to D converter, but TI calls it a master mode.
Oh, I mean, being an external master, in other words.
Yeah, right.
You're really still a slave, but you're not the master in the chain. So
right.
That's confusing as all get out.
Yeah, it is. Oh, right. So it says here, in many applications, a host processor, the FPGA, with an advanced digital audio interface can act as an audio bus master with the 6140 as a slave device. However, having an audio ADC as an audio bus master is advantageous. Okay. So that's what master mode means. So that's what I meant when I mentioned that in the email.
Yeah, so yeah, you're right. So in section 2, they say a slave device receives the clocks, B clock and F sync from an external device. In many applications, a host processor with an advanced digital audio interface can act as the bus master with the TLV320 as a slave device. However, having the audio ADC as the audio bus master is advantageous in the following circumstances. Those processor or DSP cannot output or generate standard audio clocks. Well, that doesn't apply to us because we can.
Right.
Easily synchronize multiple TLV320s. We only have one, so we don't care.
Yeah.
The host does not have a flexible TDM ASI bus to generate system required audio clocks. Well, we do, because we have an FPGA. So none of those apply to us.
Yeah. So when this is configured, this will be configured in master mode.
Which is actually a slave.
Right. Yeah.
An external master mode, then, in other words.
Yeah.
Okay, so if you turn the internal PLL on, then you can give the a lower frequency M clock, because then the PLL can generate a higher frequency internally, or you can turn it off, and then the system limits the system clock to the M clock frequency. But we could generate 49 megahertz M clocks, so what difference does it make?
Right.
So and probably the PLL disables lower noise, lower jitter.
Yeah, and the thing is, I don't even want to touch the PLL because this is going to be GPS it's going to be GPS timestamped, and the PLL will introduce jitter, which would have to be worked out. We'll need to generate offsets to work out that jitter. So that's why that I'm not even going to touch it. Now, as a normal sound card, using VLFRX tools, that's what VLFRX tools does. Is it'll generate those offsets, so it can sync it to GPS. But here, we won't need to do that with this.
Well, you're talking about we won't need to do it because we're going to feed it the proper frequency M clock in, right?
Yep. Yep.
Well, so for the different rates, we give the B clock to F sync ratio, which I believe in our case is going to be 128, because we're going to have 4 channels of 32, right?
Yep.
Which is 128 bits.
Mm-hmm.
Well, it looks like we can't go higher than, oh, that's for 48 kilohertz. Never mind. If I want to do, you want to go up to 384K?
Yeah. So, let's see. Now, the thing is, we could do some multiples of 48 kilohertz or some multiples of 44.1.
And we could do all that because you can program the clock module to generate any frequency you want, pretty much.
Right.
I think John says they got 1 hertz resolution.
Oh, okay.
But see, it talks about ratios of M clock to B clock and frame sync, but it doesn't talk about timing.
No.
You know, what's the timing relationship? I get that I have to, if I'm going to generate this, I have to generate 128 B clocks for every frame sync, and I have to generate 128 B clocks for some number of M clocks, because that's when the conversions happen. It'll depend on the conversion rate.
Yeah. That's why that I would configure it yeah, there is no master clock relationship here.
So there is a numerical relationship, but not a setup and hold time relationship.
No.
Well, that becomes easy then.
Yeah, it might not matter. As long as they're in phase, then it might not matter.
Let's see. Primary requirements of the I2C. TDM timing requirements. There's B clock to SD out. These are all have to do with B clock to F sync. This is all generated within my FPGA, and then really the B clock and the F sync are going to be synchronous with each other.
Right.
Because they're going to be generated in the FPGA by the same output stage.
Yeah.
Do you have to get off here now?
Oh, we have to go pretty soon, don't we?
Yeah.
B clock SD out. Yeah, see, I don't see any M clock relationships, so. That's weird.
Is Dan the only one on here with you?
No, John's on here too, and Joe's here too.
Mm.
Joe lives in Flagstaff.
Oh.
Yeah, this is weird.
You're not gonna like this
Why?
because we're already over 100, and I haven't even done the little parts. I just started from the bottom and did the big parts.
Did the big
first.
parts? How far over 100 are we?
106 so far, or better.
Without any caps?
Yeah.
What's the big driver besides the FPGA? It's mostly FPGA, right?
Mostly FPGA, but there's some other ones that are $4 and $5.
Yeah. Well, it is what it is.
But I started with the big parts first because I thought that, you know,
That's most important, yeah. Yeah, so Dan, we're over $100 on the BOM cost already. And she's not done yet.
Wow.
I guess he's even listening.
Yeah, he's there.
I know he's there.
Always
I was
sees the
talking,
top,
but my
always
mic's
sees,
muted.
always sees the top of your head.
How about now?
That's what.
I got the chair up as high as I can get it up. I can't go much higher.
Oh, and that's on a laptop or what?
Now I have to lower the camera here. How's that?
That's better.
Oh, that's much better.
I don't see any relationship between.
Dan cut all his hair off so he'd be just like you, honey.
Hey, watch it. Get back.
Well, I'm going to check out. Scotty, I communicated with Henry and he said 12 o'clock is okay.
12 o'clock.
Yeah.
Tomorrow?
Yeah, 12 o'clock my time, 10 o'clock your time.
Oh, 10 o'clock. Okay.
Yeah. So.
Assuming I'm not knocked down for a loop with the virus.
Yeah. Well. So anyway, I suppose if we could get together like about a quarter till.
Okay.
So that would probably
maybe a half hour before.
Yeah, maybe 15 minutes before, 20 minutes before.
So like are we going to do a Zoom?
No, we're just going to do a telecon.
A telecon, okay. Let me see if Charlie.
Ten.
9:30.
Vero.
I can't type squat on this thing. See, I can't type for beans. So how are we going to do a telecon three-way?
Four-way conference call, I guess.
I don't have any conference call numbers.
I mean, with your phone, you can't do a conference call?
I could at work, but I don't have that line anymore. So
You sure you can't do it on your phone?
maybe 2. I don't think I could do 4.
Oh, okay.
Can we do a Zoom?
We could do a Zoom, yes.
Do you have his email address so I can send an invite out?
Yes, I do. Hold on a second here.
This will force us to keep it to 40 minutes or less because we'll have more than 3 people on it.
Yeah. Okay, that's cool. Let's see if I can find.
See what?
Are they going to gag you? 40 minutes.
You're just asking for it.
Okay.
Okay, we'll see what he says.
Here, I'll take this and
Okay, and we have to go in about,
Yeah.
well, we got an hour. Well, we're supposed to be there early, so we need to go
Yes.
pretty much now.
Yeah.
I got to get going because I got to go get shot.
Okay, I will email you his address. It's actually pretty easy. It's henry@safecomwireless.com, but I'll send it to you.
And so, Jonathan, I'll try to write up a description of the I/O pins, and we can make assignments and go from there.
Okay, sounds good.
Okay.
Before you leave, I've got a question.
Sure.
I've got several people interested in this Tangerine SDR and possibility of actually doing something useful for science. When do you think, just a realistic idea of when the people around here might be able to get some kind of an operating unit or working unit? Are we looking at a year?
No, prototypes we're going to have out by a Hamvention date by May. And we're going to get, because we got funding from ARDC, we're going to get 25 prototypes. So depending on the level that the people can contribute, that'll determine where the prototypes go. And then as far as production units, really I'm for getting production units going as fast as I can after the prototypes are out, based upon the checkout of the hardware. Once we check the hardware out and it checks out good, or we fix we'll fix the problems that we have, we could do the next release, which will be a production release. And again, that'll depend upon getting some grant money to do it, because these are going to be expensive to build in quantities of 100 to 500. So, but I think that will be forthcoming. So, I mean, realistically, it could be maybe late summer.
Okay.
So, I mean, we've been messing with this for almost 2 years now, and I'd like to get it going. And it's a lot of it's my fault because I've been busy with other stuff. But
in like earning a living?
Yeah, really. But that's we downsized. A lot of our projects are completed now, so I've got time to work on this as a full-time project. So it's going to go fast, and we're all funded. So for up through the prototypes, so there's no waiting for any money or anything there. So it's these are going to come out pretty fast, and we already have the RF module done. It's already laid out and ready, but it's waiting until we make sure that we're going to have the mating connector and physical interface done so that they plug together.
Oh, details.
Yeah, and it's always a problem when you make a 3-board set, you know, they got to hook together. So I refuse to build any hardware until I actually have computer models of the 3 boards showing that they plug together. So that's what's kind of putting the weight on things. Otherwise, I'd have RF modules already.
So you're looking at summer to fall timeframe.
Right. For production type stuff. And then I don't know what's going to happen. There's a lot of code that has to be written, but these guys, they're so impatient waiting for me that they've written simulators for the data engine. So they've got the software code that runs external to us. Is a lot of it is going to be done already by the time the data engine comes along. So it'll just be us working on the FPGA code. That'll be the holdup. We'll be the last in the line. And we're going to be porting some of this from one of our existing products. So I don't envision it's going to be. I mean, I don't want to minimize the complexity of it because it is complex. But we've got some experience in the pipe here, so it won't be like we're starting from zero.
Okay, sounds good. I just wanted some idea I can tell these other people who are interested in getting going.
Yeah. And do you ever get down to flea markets in the Phoenix area? Or Tucson's kind of far for you, but and we haven't had any flea markets in the past year, but I think they're going to be starting up again here.
All depends. The virus is in the driver's seat.
Yeah. But like I said, when we all get vaccinated, or most of us are by the summertime, I think it's going to loosen up quite a bit.
I'll have to see what happens there. Yeah.
Okay. I mean, I was just thinking, prior to the pandemic, did you used to get down here for flea markets or?
Occasionally.
Okay.
Occasionally, I've been hiding at home. The girlfriends insisted on keeping me halfway safe.
Yeah. Yeah, but because I used to bring out to almost every flea market in the Phoenix area, bring out my SDR demo and run it. But I got tired of it because it was the same old stuff, and now we're going to have new stuff, and it'll be more exciting. So I'll probably want to start demoing that at flea markets.
Okay. Well, let me know if there's anything I can do to help. And okay. I made an offer. Oh, what's his name? I forget now. Anyway, one of the people that was here today made an offer that if we want to get some of these things down to the Southern Hemisphere, I could help out with a couple.
Okay, so you were the one that wrote to Dave, right?
Yes.
Okay. Got it. Good. Yeah, because he wrote me a note, and I'm going like, well, what should I do? Should I answer him or what? I don't know what to do. And it kind of got put aside. And then you know how it works. If you don't answer it right now, then it gets stuck in the backlog, and sometimes you forget about it and you don't answer it at all. But I think Dave answered you, right?
I did not see an answer, but well, he did answer. He gave me some ideas, but nothing very concrete.
Yeah. Okay. Well, welcome. Come back often, and I'm sure that we'll find something for you to do because there's lots to do. So, and people with skill sets are definitely needed. So.
Okay, well, my expertise in timing and frequency stuff, I did pretty well in the last frequency measuring test.
Okay, well, the Personal Space Weather Station, the low-cost model that's being sponsored by Case Western Reserve, they actually have their own. Well, they don't have their own, but they participate in the FMT also. So they're because a lot of the things they're doing, they're measuring Doppler shift from WWV on the different frequencies. So they need very accurate measurements because the Doppler shift, you know, is in millihertz. So that may be something that you're interested in. It's supposed to be a low-cost version, and the prototypes are coming out now. The prototype version 1s, John McGibbons is working on version 2. And if you're interested, sounds like you might be a good site for a prototype up there. So.
Okay, well, my interest is how do I determine the frequency shifts? I was lucky and got down to 1/100th of a hertz, but that was luck.
Well, these are going to be GPSDOs, but you know that's not necessarily a guarantee of anything. It depends on how you did it, right?
Well, yes, well, I'm good to a couple of parts in 10 to the 11th here.
Yeah, and that's kind of what we're aiming for. Better, a little bit better than that for the our GPSDO. So you, in fact, yeah, I'm going to be giving a talk Saturday at TechCon, Ham TechCon, I think it's called. It's in West Central Florida, but it's Zoom sessions. So I'll be giving a talk, a 50-minute talk on HPSDR. I mean, sorry, on the Tangerine and all the hardware and what we're going to be coming up with. So that if you aren't familiar with Tangerine at all, and if you haven't watched any of the videos, that will be a good time to get up to speed real quick.
Okay, be careful about how much frequency accuracy you promise. I saw somewhere where this was going to be good to parts in 10 to the 13th, which is simply not attainable in a.
No. Did somebody say that about the Space Weather Station?
Yes.
Oh, okay. Well, I think that's not really realistic. It's more like 10th to the 11th.
10 to the 11th is pretty high quality for home use.
Yeah,
without having a cesium or something.
Well, we're using about $170 GPS, and we're using a Silicon Labs jitter reducer and synthesizer chip. And so really it would be good for you to talk to John Ackerman, because he can give you a lot more information. In fact, I don't think the videos are up yet on the Hamcation talk we gave 2 weeks ago. But he has a 10-minute segment in there describing exactly what's going to be in our GPSDO module. So you would understand all of that hands down. So
yeah, well, one part in 10 to the 11th is doggone good.
Yeah, and he's talking because he has Allen deviation charts showing that we can achieve that eventually. I think I don't know whether we're down below 1 part in 10 to the minus 11 at crossover point or not. Where we're taking the short-term stability of the oscillator and the long-term stability of the GPS. And
yeah, but it's that short-term stability and temperature fluctuations that'll get you. I've
right.
been there.
Yeah, but we're using the TCXO, and it's a high-quality one, so it's better than your average. And the reason we're making it modular is so that if we come up with a something that is better, and as always happens as time goes on, then we can make a new module with the new hardware on it, and we can get better accuracy.
I would sure like to see part in 10 to the 11th, but that's and the TCXO just doesn't sound feasible for that. But whatever, we'll see we'll see how it comes.
It's GPS steered, but still for short term that doesn't help you much, right?
Yeah, well, I've got ovenized stuff here, and I'm hard put to do more than a couple of parts in 10 to the 11th.
Okay, well, that's I may be leading you down the path, but that's what John is claiming. So we'll see if we actually can do it or not.
Well, if you need it checked, I can probably come close.
Okay, that's good. So we'll put you on the short list for clock module testing when we get them. Well, the plan is to take the clock module that we'll plug onto the Tangerine board, and John is going to build a carrier board that will convert the clock module into like a lab frequency GPSDO that you could put on your shack on your bench in your shack, so that you'll be able to use it for something other than Tangerine.
Right, and that's a huge advantage because you can lock a frequency counter and get your frequency to easily, quickly, almost instantly to 1 hertz or better.
Yeah, and we're going to have an external reference input. So if you've got a very high grade standard, that will help. So.
Okay, well, let me know if I can help, and I'll check in here as often as I can. Big problem is everybody wants to do everything at 0200 Zulu on Mondays.
Yeah,
I'm not kidding.
We've been here for a year and a half, so there.
Yeah. Okay. Well, I had an ARES net and a Skywarn net this evening, and seeing as I'm managing this stuff, I got to kind of pay attention. Okay, well, take care.
There's another net on Thursday morning at
week.
not the ham size, the personal space, the low cost personal space weather station meeting is on Thursday at 10 a.m. Eastern. So that's 8 a.m. our time. And then the ham
Okay.
side meeting is every other Thursday at 1 p.m. our time. So.
Okay.
And you're welcome to come to all of those. I think if you get on do you know where the TangerineSDR list is? The email list?
I send in an application, but I haven't heard anything back.
It should automatically subscribe you. I don't have to intervene. But if you don't get connected, I'm wa2dfi@arl.net also. So if you need to contact me, if you don't start getting emails, because the info for how to log on to those other lists, it comes out there. So that's
Okay.
one of the
I
places.
do not have that, and I just signed up yesterday or something like that.
Okay, it should be fairly instant, but it's not streamlined. We've had trouble with it occasionally. So people sign up and then they don't get any email messages. And
okay, I had to go to the location, what is it, the email server to find the URL for here.
Okay, so you mean you went to TangerineSDR.com?
Something like that.
And there's instructions on how to subscribe there, right?
It was not very easy.
Yeah, I know there's a TeamSpeak session, but we don't do that anymore. So that was a little difficult. But the email server should be relatively easy to sign up on. I mean, it's just it's mailman.com. I mean, Mailman, a Linux server that somebody runs. I think Tapper runs it, doesn't it, Dan? Yeah, because John Ackerman is always the one in there fixing the problems with it.
Yes,
So
yeah, John actually manages that.
yeah. Okay, I got to run because I got to
Okay,
go.
good luck. Have fun.
Thanks. We'll see you in the morning.
Okay.
Night, Joe and John.
Have a good night. 73.
73.